Today we'll talk about the system design of e-commerce, and this includes a system like Amazon, Flipkart or eBay. So let's jump into the functional and non-functional requirement of this system design. So functional requirement here are that the user should be able to create their profile, and when user creates a profile, so they should be able to store their name, email address, phone number and their postal address, and they should also be given a provision to store their preferred way of payment. So they should be able to store their credit card number. You should not allow them to store the pin of the credit card and all those confidential detail, but at least the credit card number and expiry date, all those things they should be able to store, and that too in an encrypted manner. We'll not talk about the encryption and all, it's just the basic detail, and we'll talk about the high level design of the e-commerce system here. So once user has created its profile, there should be a provision to onboard product. So user can either buy a product or he can also be a seller. So he should be able to onboard the product that he wants to sell. Next thing is that once the product has been onboarded, so user should be able to, and when I say user, when I tell user in terms of product, it means it's a seller, and when I talk about user in terms of buying and all, so it's like the normal user who is going to consume the product. So onboarding will be done by the seller, obviously. Profile will be common for both of them. Select product, so it will be the consumer who is going to select the product. So there should be an option to select the product or search the product. So what is the difference is that when he is going to make a search, so he should be able to type something in an search box, and based on the text that he has written, he should be able to get some product there. And select product is like we should give a facility of catalog where a user can go and click on a tab where it says that it's for sports section or maybe fashion or electronics like that, and he can drill down into that particular option and go to different brands. Like if someone has selected electronics, he should be able to drill down and select what electronics they want, maybe a mobile phone, computer or a headphone. That kind of facility should be there. Once a user is able to select, then he should be able to add that particular product in a cart. And cart is basically uh, the cart that you see in any shopping center where you can keep the product that you want to buy. You may not buy it straight away, but it should be preserved there for some time, or maybe till user has bought it or he has not removed from the cart. So that should be like a persistent thing where user can store the items that they want to buy. And once the cart is done, then the user should have the option to go ahead and check out that cart. And by checkout it means that they should proceed to buy that item. So when they go for buying, they should be able to make the payment, and if the payment is successful, then the order should be placed. So all those will be the functional requirement that we have. And non-functional requirement here is first and foremost is consistency, because we should be able to host this application both on a mobile device, web application. So user, if he or she is using an Android or an iPhone or a laptop, it should not matter what uh, recommendation that they are getting or whatever product they added it in their cart. So it should show the same thing in all the devices, and it should be available, and latency should definitely be very low, because if latency is high, then no one will come to this particular website to buy their product. They will go to another website. So these are the high level requirement that we will deal with, and like always, we'll start with the few requirements at a time, and then we'll build the system in the end. So let us look at the very basic requirement, like these two, user profile and the product onboarding. So what we'll do is we'll have a service here, and this service will be a user service which will talk to a client. Now the client will have a device with them. It will either be a mobile device or a user interface on a on a laptop or somewhere. So that particular browser or the UI should send some JSON request to our user service, and what this user service will do is it will basically onboard our user, or it will be the gateway to the user. So if user wants to check out, if he wants to add some address, so this user service will be able to help the user to add address. It should be able to help user to add the credit card information. This guy should be able to show the previous order that the user has made, and all the profile details, basically the username, the phone number, the address, email address, everything will be handled using this user service, and it will have its own database. And this database can be an RDBMS, it can be a MySQL cluster, and we can have some provision here that will store past 6 months or 1 year of the data here, and maybe archive the rest on to an HDFS. But for simplicity, for now, we'll consider that all the data will reside here in this database. So any request that is coming from the user related to the profile, the previous order, or if they want to edit their address, or anything that is related to user, so it will be routed through this user service. Now from the seller side, if a seller wants to sell one of his product, so that product has to be onboarded into our system, so that our system knows that okay, this is the seller who wants to sell a particular product. For example, a seller can be like a Dell Technology, and Dell Technology wants to sell their laptop on Amazon. So what they will do is that they will create a profile here, and once they have created a profile, they will onboard the product. So once they onboard the product, when they have to onboard the product, they will get a UI here, where there will be bunch of labels and text boxes which Dell Technology has to fill. So they will fill in with the category, under which category they have to put this product. Then they will enter the details like description, configuration, and other details like where is the warehouse present, from where this product will be shipped from, and all those details will be filled by the user. That detail will be dumped again to this service in form of JSON, and what this service will do is it will store all these information into a database. And what this service also will do is it will put all those details into an Elasticsearch database also. Why this is required is because we need to convert the description, the heading, whatever we have got from the user, or the category, into an Elasticsearch, so that when someone searches in a text box, that facility is made available to the consumer. So that is why whatever detail is captured by the this client from the UI, so that should be inserted both into a database and into Elasticsearch database. So what kind of database will be this guy? So the product service will deal with different kind of seller. For example, here we have Dell. So Dell is selling a laptop here. Dell can also sell some server, or just a mouse, or a keyboard. Other than Dell, there can be other seller also, like someone who is selling a t-shirt or a jeans, or maybe LG who is selling a fridge. So all these products will have its own configuration. A t-shirt will have a size like small, medium, large, whereas a laptop will have some configuration related to the RAM, hard disk, all those things. So what we see is that this onboard product service, it is not dealing with the range of product which has a fixed schema. So if we are dealing with something like this, then this database should be a document based database that makes the best contender to handle all the different kind of product for this particular service. So RDBMS, it will not be able to handle this, because you will have to create multiple table for different kind of product, and handling that will be very hectic. So a document based database will be the ideal choice for handling a system like this. So you can go with MongoDB kind of system, a kind of database. So we'll have a MongoDB here, an Elasticsearch here, and once we have onboarded our product, then this product service should send a notification into a distributed queue. So this queue can be Kafka. And why this notification is required is because there will be multiple listener to this particular queue, and based on this event that a new product has come, few of the things has to be done. Now The first thing that needs to be done is the inventory needs to be updated, saying that okay, I have a new product from this particular seller. So what inventory service will do is it will listen to this distributed queue. As and when the new product has been onboarded, it will listen to that particular event, and what it will do is it will pick up the details that has been sent by this product service, and those details needs to be updated in the inventory database. Why this is required is because the same inventory or the same system like we have, it can have an LG fridge that is coming from multiple seller, because LG does not directly sell the fridge. They sell directly, but they also give the agency to different other people who will be selling fridge of LG on behalf of LG. So they all can come and they can be onboarded onto our system and they can sell from our portal. So that is why an LG fridge can come from seller 1. It can also come from, same fridge can come from seller 2. So the inventory will be updated with that kind of fridge and quantity as 2. And when we store all these information, we have to store the seller information also, that this particular item is coming from quantity 1 is coming from seller 1, quantity 2 is coming from seller 2, all those information, so that later when we have to do delivery, we should know that that quantity that we have reduced, it has reduced for which seller, so that we can know the warehouse from where that particular item has to be picked and shipped to the user. So that is why this inventory service will have the detail of the seller, it will have the detail of the quantity, it will have the detail of the product, like which product it has updated into its inventory database. So this database again can be an RDBMS. It will have a fixed kind of schema, and you can have a MySQL cluster here also. You can combine these two database and have one database, but since we are working with a microservice kind of architecture, it's better that these two have two different database. And why it is required is because there can be a day like Flipkart or Amazon, they have that great sale and the big billion day kind of thing. So that time it may happen that user service is loaded but inventory service is not loaded, because people are just coming, browsing, adding it into their cart, but they're not buying. So to reduce all those kind of uh, call on our internal database, so we can, it's better we segregate all these services. Now, the third service that we are dealing with here is some Spark job and an SDFS cluster. So why this one is required is this will be carried down on the other part of this particular system design also, and the functionality is very common across. So when we will talk about select product, cart facility, proceed to buy, there also we will have these two components where we have a Spark job and an SDFS cluster, and this is required solely for the purpose of coming up with a recommendation. So when this user service or the onboard service, it onboards some data here, or some user, it has browsed through some product and it has added some product to its cart, or he or she has added some credit card information, or they have added some address. So all those information will be passed on to this distributed queue, and Spark job will be, again, there can be a service here. So if you are using Java, you can write a microservice here, or using Python also you can write all those service, and you can use Spark jobs there to basically run on those data. So these data will be very unstructured data. What these jobs can do is it can aggregate all these data and it can put it into SDFS cluster. So later on, with the details, like if user has added a new address, a postal address, then maybe a recommendation service can show this particular user that what are the different products that his neighbor or her neighbor are buying at the moment. So all that kind of things can be done if we have a, if we put all these information in a distributed queue and run some Spark job on top of it. So this is solely for an analytical purpose, and it will be a very important part. It will be the core part for the recommendation system that can be built later on. So this covers up the user service and the onboarding service, or onboarding of the product service. Next we'll look at the cart service. So not the cart service, next is the search product. So when we have to search a product, so there are two ways: either you select the product or search product. So selection is when you go to the drop down, you go to electronics, click on the drop down, come down, select mobile, and you go to a certain company. So this search product will have various endpoints, and those endpoints will have the details, like you get a product based on category, so that category can be an electronics, or it can have an endpoint like category slash device type, so it can be like electronics slash mobile or electronics slash a computer, and based on that you can directly make a search into this redis. So this is a distributed cache that we can put in between. So based on the request that we have, you go to the cache, pick up the data if it is available. If it is not available, then go to the database and pick the data. Now this database is again the same database which we populated here, the MongoDB that we were talking about. And why we need a cache here is because for faster IOs, and especially when you are searching a product, so you want the response very fast. And in case of, like, again, big billion days kind of scenario, you will have lot of search on product, and the load will be very high, so you don't want to increase the traffic or congestion on the database. That is why a Redis is required here. Now the second thing is that if someone tries to search a product based on the text box that is present or that has been given to the user, so for that kind of scenario you will redirect the search to the Elasticsearch database, so that based on the name or the tag that has been entered, you will fetch the list of product that can be shown. So that is why initially also we populated the Elasticsearch database, and here also it will be used whatever we populated. Now, once we have retrieved the data from either from the cache or from the database or from the Elasticsearch, this product search should pass on the result to a filter service. And what this filter service will do is it will check whether that particular product can be delivered to the user or not. So it can happen that we have a product that is present in our cache, it is present in our database, but the thing is that that product is available only for someone who is there in Bangalore. It cannot be delivered to someone who is residing somewhere in Delhi, for example. So that is why a filter service is required, which will do a search, or it will do a filtration on the list of the output that we got for our search, and it will further filter the result from there. So if that particular product cannot be delivered, so how the filter service will check that whether that product can be delivered or not? So it can basically go to the database or the cache, and it will check for the user's location, and it will also check for the location that or the address of the user and the address of the seller that we have already captured as part of the onboarding of the product. And we can have some service, some internal service, which will tell me that whether there is a route from the seller's position to the user position or not, or there is a route to send uh, those products from one warehouse to the another warehouse which is near to the user, and then some other delivery option is present or not. So I've not discussed in detail about that part, but there should be a filter service, because if suppose you add that particular product to your cart and you want to buy, and later on you realize that you are not eligible to buy that product, so it will be a very bad user experience. So a filter service is really required here. Now again, this search product will keep on populating or keep on sending some message to the distributed queue, and this is for the purpose of, again, for the recommendation purpose. So this guy will send some detail that user A has searched for this product or this kind of product or this category of product, and then all those detail can be put into a HDFS cluster, so that later on recommendation system can come up with some detail, like maybe in this particular area people are looking for this kind of product, or in this particular time of the year someone is looking for this kind of product. So based on all those details that is captured into HDFS, a recommendation system can be built on top of that. So that is how our search product feature will work. Once we have searched the product, then we will add it into our cart and we'll proceed to buy that product. So the cart service will look something like this, or the overall cart service plus the payment service will look something like this. And cart service will again have its own database, because you can add something to your cart today and you won't buy it today, you want to buy it like 10 days later. So that whatever you added into your cart, that should still remain 10 days later also. And it can happen that you added it from your web browser and you want to buy it from your mobile phone, so that consistency should be there. So that is why there should be a cart service, and the cart service will have its own database. Now whenever we add something in our cart service, that notification again will be sent to distributed queue, and there will be some set of the jobs, the Spark job, which will again capture that detail that user one has added these kind of product into the cart, and later on you can show a recommendation that these are set of the product from the same category, you can also buy these if you want. So that is why that notification is required, and we will have a job on top of that. Once we click on the button that I want to buy these, the request will be moved from cart service to the payment service. Now payment service will talk to the filter service and inventory service both. The reason being, you might have added a product into your cart today, and you come to, or you click that buy now button like after 10 days or 15 days. Now between these two events, it might happen that the warehouse from where that product has to be delivered, someone already bought that product and you are short of that particular product in your nearby location. Or it might happen that overall the inventory itself is empty, so you don't have that product available now. So what will happen is payment service will first talk to the filter service, and it will check whether this product is available in the nearby location or in the serviceable location or not. And then it will go to the inventory and check whether that product is available in the inventory or not, or it can go either ways basically. So these two requests can be redirected in either of the ways. That's up to you, however you design. It makes sense to go to the inventory first. So you go to the inventory and then go to the filter service. And once you have a positive nod from both this service that yes, it is available, yes, it is serviceable, then the payment service will ask you for the details of payment, and you can basically input, you can be redirected to a payment gateway. And once you have a successful payment, then an event can be put into the queue that the payment is successful. If the payment is failed, then in that case you go back to the inventory, update back the record that you blocked initially. So you should, when you come to payment service, you should block that quantity of the item in the inventory service. And if the payment is failure or timed out, so in all those events you go back and release that product back into the inventory. And you can also put the failure event in a distributed queue to maybe to understand that for a particular kind of card you are getting a frequent failure, or when you are doing a payment from particular kind of gateway, so that time the failure is more for all those kind of services. Otherwise, for the successful payment event, you can put that event in the queue, and the order tracking service will be listening for all such event where the payment is successful. Once the order is successful, this tracking service will pick up that particular order, it will talk to user service, and you can basically see in your user profile that how the order is moving from the warehouse to your particular place and how much time and date it will take. All those details will be served by this order tracking service. So this is how you will, means I have designed the card service and the payment service, and the overall picture will look something like this. When everything comes together, we have the user service, onboarding service, the search service, card service, the filter service, the payment, and inventory, and also the order tracking service. So this is how I came up with the design, a very high level design of the backend for any e-commerce website. So hope this was helpful, and do like and share this video, subscribe to the channel to get further update. So let me know in the comment section if I missed something or if something